So in this lecture, we're going to talk about the graphs of sine and cosine. Now, if you notice, these graphs actually look very similar. They both have this same curved structure. However, they start in different places. So sine starts at the midpoint between max and min, while cosine starts at the max. So you could say, looking at the sine function, that the cosine function starts here. And there is a relationship between sine and cosine. But the important points here, some important points for sine and cosine, have to do with what the pattern is that repeats. In other words, this hump right here, that's not what repeats over and over. If the hump just repeated over and over, it'd look like that. What repeats over and over is this hump and this valley. That's what repeats over and over. And same with cosine. Cosine starts from the top of the hill, goes into a valley, and to the top of the hill again. These are the patterns that repeat forever with sine and cosine. And so between these blue circles that I have written, this is 0, and this is 2 pi. And what this all means is that we say the period is 2 pi. The period is that section that repeats. So what repeats with the sine function? It's this chunk right here. This chunk is what repeats over and over. And that chunk that repeats over and over, we call the length of that chunk a period. And the period for sine and cosine are 2 pi. Now, going forward here, I'm going to primarily, or actually I should say solely, focus on the sine function here. But I do want to make it clear that everything I'm about to say is exactly true for cosine. So sine and cosine, everything I'm about to say today, they're all the same. Sine has a period of 2 pi, and so does cosine. And period specifically means the length of the interval that gets repeated. So another piece of terminology. So period is one piece of terminology here. And the next one is going to be amplitude. And amplitude specifically means what is the distance from your central axis to the max and the min. And if we look at that amplitude for what I have graphed here is 1. And you can see the maximum goes up to 1, and the minimum goes down 1. And this is always true for sine and cosine. The min and the max will always have the same distance, and we call that the amplitude. So let's take a look at just sine. All by itself here, regular old sine, like you're probably used to seeing it if you've seen it a lot before. And what we're going to do now is we're going to look at, well, what happens if there's a number before the sine? And that number before the sine is the amplitude. In other words, if we go back to this picture here, this amplitude is the leading coefficient of sine. Now, in this case, the amplitude is 1. But this amplitude changes if we change A. So, for instance, here is sine of x. And here is 2 sine of x, the blue line. And you can see that the blue line, notice the blue line starts in the same spot as the red, and its period is the same. So the period doesn't change with amplitude. The period stays the same. What gets repeated, the length of this interval that gets repeated is the same. What changes is how high the function goes and how low it goes. That's what the amplitude controls. This number in front of the sine function. We call it the coefficient. That coefficient gives you the heights of these bumps. So let's say we go to 3 sine x, which is the green line. And you can see the green line now goes to a maximum of 3 and a minimum of -3. This is what the amplitude controls. It controls how high these bumps are. And you can see the red line is 1 amplitude, the blue line is 2 amplitude, and the green line is 3. So question 1. Looking at this function, what is the amplitude? So we want to take the central axis that splits it in half, and then we want to look, how high does this go from the central axis? It goes 0.5. And that's the amplitude. So this is what we have so far. We're going to multiply the sine function by some number, and that changes the amplitude. Now, we're going to multiply the input by some number. And this number that we put here affects the period. Now remember, the period is the length of that interval that gets repeated. If we multiply x by some number, that will change the period. That will change the length of the interval that gets repeated. So let's check that out. Here again is regular old sine of x. And now I'm going to multiply x by a number. I'm going to multiply it by 2. So here's sine of 2x, the blue line. And now notice the blue line no longer has the same period. So for the blue line starts at 0, it goes to its peak, it goes to its valley, and then right here is where the period ends. This is the period for the blue line. While the red line, the original sine function, you can see it goes to its peak, it goes to its valley, and it ends right here. This is the interval of regular old sine. This is the period 2 pi. So what is then the period of this blue line? Now, if you look, you can see the blue line completes one period when the red line completes half a period. And so from this, we can figure out then what is the period of the blue line. The period of the blue line is half of what the regular sine function is. And so we can conclude then the period of the blue line is half of the period of sine. And so this period is just pi. Now, ultimately, this comes down then to a simple equation. Remember, the period is always 2 pi over b. Now, in this case that I have graphed, b is 2. And so we have 2 pi divided by 2, which is pi. So let's check out something different. How about 3? Now, I got rid of the sine 2x because it'll make the graph look a little cluttered. So that one's not displaying. So let's multiply x by 3 now. And look at the black line. The black line, here's the hill, the valley, and then the black line period ends right here. This is the period of the black line. Now notice with the black line, here's one period, and then here is a repetition, and here is another repetition. In other words, there are 3 repetitions of the black line for one red line. And so we can conclude the period of the black line then by comparing it to regular old sine. We can see that there are 3 periods for one period of the regular sine function. And b in this case is 3. So we get for the period then 2 pi over 3. And ultimately, this 3 is telling us how many repetitions we make before we get to the actual period of the regular old sine function. Now, I'm saying regular old sine function so that you think of just sine of x. There's no numbers in there. So question 2. Now the red line I have graphed is the regular old sine function. That's the red line. By looking at the red line, what is the value for b then of the blue line? So the red line, here is the period for the red line. That's the regular old sine function, and that's 2 pi. Now notice for the blue line, the period ends way over here. The period of the blue line is twice that of the red line, which means it's 4 pi. Now we know the period is 2 pi over b. And by looking at the graph, we can see the period for the blue line is 4 pi by looking at the graph. And so then we can just do some cross multiplying here to find out then that b must be a half. And that's the answer. So the blue line is sine 1/2 x. So here's where we're now at. We talked about A is the amplitude when you multiply the function by a number. We talked about now what happens when you multiply the input by a number that affects the period. And now the next thing we're going to do is throw in a C. Now this C affects the phase shift. Now the phase shift means how we're moving the function left or right. So phase shift is commonly used when you're dealing with angles, but it still has the same algebraic meaning. When you do this operation here, when you subtract a number from the input, this moves your function left or right. Let's take a look at that. Now, in this case, notice B is 1 and A is 1. Now, A doesn't affect the phase shift. This doesn't affect the phase shift. However, B does. Now, if B is 1, then the phase shift is C. In other words, if B is 1, then how the function moves left or right will be the number C. Let's look at a graph on that. So I'm just looking at this general form right here. Sine of x minus c. Now on the graph, the red line is a traditional sine function there. And then the blue line is this one that has a pi over 2 phase shift. Now what does that mean? That means we took the sine function. The sine function is the red line. We took the sine function and we moved it to the right pi over 2. So the normal sine function starts at the origin, but this blue one we shifted so that it now starts at pi over 2. And this is what we mean by a phase shift. It means how we move our function left or right. If c is positive, the function moves to the right. If c is negative, that will move the function to the left. So again, C is the exact change of the start position when B is 1. However, when B is not 1, then the phase shift is no longer exactly C. In other words, it has to be in the form x minus c. Has to be in this form. But it's not anymore. Now we have bx minus c. And there's a way to get this form to look like this one. And we can do that by factoring out this b. Like this. So if you want to distribute, if you distribute b times x is b of x, and b times c over b means the b's will cancel and you're left with c. So all we're doing here is factoring out a b. And once we do that, we now have this form of x minus a number. X minus a number means this is the exact phase shift. So the exact phase shift, the amount we move the function left or right, is c over b. If c over b is positive, then the entire function moves to the right, whatever value c over b is. If c over b is 2, then the entire function will move 2 units to the right. If c over b is a negative, then that moves the function to the left. So this controls where the function is situated. You can move it left, you can move it right, or you could just not move it at all. If you're not going to move it at all, then c over b must equal 0. So let's check this out. Sine of 4x minus 8. What is this phase shift? Now again, the phase shift is not 8 because b is not 1. Now, there's 2 ways that we could go about this. You could either directly remember that the phase shift is c over b. However, I think it might be more intuitive if we just put this into standard form of x minus a number. And what that means is we're going to factor out this 4. And if we do that, we will then have x minus a number. And once we're in this position, this number then is the phase shift. So our phase shift here is 2. Now the other way you could have gone about this is to remember that the phase shift is always c over b. And so if we look at our function, we see c is 8 and b is 4. And 8 divided by 4 gives us 2. Let's take a look at this on a graph. So here is sine of 4x minus 8. Now, the sine function normally starts at the origin, but the phase shift will move the function left or right. Now, in this case, our phase shift is positive, which means the function will move to the right. And the phase shift is 2, which means the function is starting right here at 2. Now that can be complicated with these repeating functions because you might be thinking to yourself, well, couldn't it start here or couldn't it start here? Sure, it can. But given this equation, we would say this sine function starts here. So question 3. Given this sine function, what is the phase shift? So again, there's two ways you go about this. Whoops. There's two ways you go about it. You could either factor. So if we factor out a 10, that's what we would get. Which means the phase shift is 2/10. Now, the other way you can go about it is just to remember the phase shift is C over B. And C is 2, and B is 10. 2/10. And simplified to 1/5. That is the phase shift. In other words, this sine function right here is moved 1/5 units to the right. So it doesn't quite start on the origin. It starts 1/5 away from the origin. So now here's where we're at. A is the amplitude, multiplying a function. B affects the period when you multiply the input. The phase shift is C over B. And you get a phase shift when you subtract a number. Well, subtract or add from the input. If your number is subtracted from the input, that moves the function to the right. If you add a number to the input, that moves the function to the left. Now there's one more thing. So we have A, B, C, and D. So now we're just going to add or subtract a number to the entire function. And this is a vertical shift. When you add or subtract a number, that moves the function up or down. If D is positive, you move it up. If D is negative, the function moves down. So here is sine of x plus 2, the blue line. So the red line, regular old sine, you can see starts at 0. And then sine of x plus 2 is just moved 2 units up. Instead of starting at 0, it now starts at 2. And you can look everywhere the separation between these two functions is 2. That's what this does. It's a vertical shift. It moves a function up or down. Here is minus 2. Notice the blue line has now shifted down 2 units. And it's done that everywhere. Putting them all together, there they are. So regular old sine right in the middle. The green line is when we add. Adding a number moves it up. The blue line is what happens when we subtract a number. So the blue line subtracts minus 2. So again, adding a number to the function will move it up. Subtracting a number from a function will move it down. So question 4, looking at this graph, what is the vertical shift? In other words, this function I graphed, what do you think D equals? Well, regular old sine starts at 0. And you can see by the graph, this new one is shifted -8 units down. And so D here must be -8. Because this red line has been shifted 8 units down. So putting everything together, here is this section. Now I want to be clear that all of this is exactly the same for cosine. It's exactly the same for cosine. Everything I've said. So A is the amplitude. That affects how high the bumps are. B affects the period. And you're going to want to remember, period is 2 pi over B. C affects the phase shift. The phase shift is what moves functions left and right. And you're going to want to remember, the phase shift is C over B. And then finally, D is the vertical shift. That's what moves the function up or down. So going back to 151, where you actually have seen this before, most likely, is that the amplitude, when you multiply a function by a number, that stretches it. And in 151, you probably call that the stretching factor. Multiplying a function by a number will stretch it up or down. Now, when you multiply your input by a number, this is also a stretching factor. But this stretches it left and right. So the amplitude stretches things up and down, while B stretches the function left and right. C, when you subtract or add a number to the input, that moves the function left and right. And if you add or subtract a number to the function, this will move the function up or down. So amplitude and B, these two things are stretching factors. The amplitude stretches things up and down. B stretches things left and right. While C and D actually move the function. So C moves the function left or right, while D moves the function up or down. And these are the 4 things you're going to want to remember for this section. A stretches in the vertical, B stretches in the horizontal, C moves the function in the horizontal, and D moves the function in the vertical. And that is the summary. This is everything you need to know for this section. And I just want to state this again. Everything here is true for cosine as well. So everything said here is the same for sine and cosine. The amplitude stretches cosine, the period stretches cosine, the phase shift and the vertical shift move cosine. all the same way it affects sine. And that is the lecture.